Hello everybody. In this video we're going to deal with factoring special cases, and in this case we're going to be dealing a difference of two squares. Okay, we're going to be dealing with a polynomial of difference of two squares. Now in order for it to be a difference of two squares is that both terms have to subtract from the other, meaning that we have to have one term being subtracted by another, just like we have here. Okay, also we need to have both terms need to be perfect squares. Now, if you forgot what a perfect square was, then it's pretty much just a number that whenever you are able to apply the square root of it, it should give you a whole number. So, in 64, it should be a square root. These are a couple of examples of square roots. I mean, not square roots, I mean perfect squares. So 64, 8 times 8 will give you 64. 7 times 7 will give you 49. And 6 times 6 will give you 36. Those are examples of perfect squares. Now, examples of not perfect squares are 45, 37, simply because if you're able to apply the square root of it, then they will probably end up giving you a decimal number. And you cannot find a whole number that, whenever it's multiplied by itself, will give you 45 or 37. Okay. Now, the formula we're going to deal with in this video is we're going to have a squared minus b squared equals a plus b times a minus b. Now, what's really important about here is that both a's have to be on the same side as the other one, and b has to be on the same side as the other one, but they both have to be opposite signs, so plus and minus. And if you're wondering whether the order of that these go, then plus or minus go, they don't necessarily matter. We can write them as a minus b times a plus b, like we have here. Okay. It's pretty much just the same way as saying 3 times 2 gives you 6, or 2 times 3 equals 6. It's the same thing. So let's just start off, go ahead and begin. And first step that we need to do whenever you have a problem like this is you have to check whether each term is a perfect square. Okay, so is x squared a perfect square? Yes. We have x and x. So 16 a perfect square? Yes. We have 4 and 4. Now, an easy way to remember whether a variable is a perfect square is by noticing the exponent. Whenever the exponent is an even number, it is most likely a perfect square, and because you're able to apply a square root to it, and it'll find the exponent that relates best to this one. Okay, so hopefully we're still together here. So we have x plus 4 and x minus 4. Okay. Now, using FOIL is an easy way of double checking your answers. I won't be using FOIL that much in this video. So where we have x squared minus 4, but I'll go ahead and double check with this one. And then we have positive 4x. And then we have plus, oh sorry, not plus, it'll be negative 16. Negative 16, in which we have x squared minus 16. Okay? Now if you notice, these right here, x minus 4 plus 4x, these would cancel out. So we have x squared minus 16, which is originally what we had up here. Okay? Now, in our next problem, we have a coefficient to deal with. So is x4 a perfect square? Yes. Is x squared a perfect square? Yes, we have an even exponent. Is 49 a perfect square? Yes, we just did it up here. So break this down. So we have 2 and 2, x and x, and right here we have 7 and 7. To plug into our formula, start off here. We have 2x right here plus 7. Start off the next one, 2x minus 7. Okay, and that's it right there. That's how you factor a difference of two squares. Alright, so we have, next case, we have 81. Perfect square? Yes. X squared a perfect square? Yes. Is 1 a perfect square? Yes, it is. For 81, we have 9's to deal with. X squared, we have x's to deal with. And then 1. A number times itself that equals 1 is also 1. Okay? And we just gotta put it into our formula. 9x, and then we have 1. And then we have another 9x. and then we have a minus 1. Okay, so that'll be it for that one. Alright, so hopefully these are pretty easy to pick up. We have 49 and p to the power of 12. Is that a perfect square? Is 49 a perfect square? Yes. P to the power of 12, it's an even number, so it's a perfect square. 9 a perfect square? Yes. Is q to the power of 6 a perfect square? Yes, it is. So let's try and split them up. So we have 7 and 7. 7 times 7 gives you 49. P to the power of 6 and p to the power of 6. Now try to remember that we're using properties of exponents here whenever we're multiplying, because p to the power of 6 times p to the power of 6, same base, you just need to add the exponents. So 6 plus 6 will give you 12. Okay, so next is break this down. We have 9 to 3, and then we have q to 3, and then q 3. Put into our formula, we have 7p6 plus 3q3, 7p6 minus 3q3, and that will be it. Okay, now our next case, we have x cubed minus y to the power of 4. Just a moment. Y to the power of 4. Now, is y to the power of 4 a perfect square? Yes. X to the power of 3 a perfect square? No, it's not. Okay, so South Park face. So it's not a perfect square. We cannot find another number. We can't find another I guess it's like exponent that whenever it's multiplied by itself would give you 3. That would give you the same exponent. Okay, so whenever we have an odd exponent, it's not a perfect square. Okay, so here it is. Now whenever we deal with this, with a situation like this, explain to us why it's not a perfect square. So this is a perfect square, but this isn't a perfect square. So we're not able to factor a difference of 2 squares, only because x to the power of 3 is not a perfect square. Okay, so that's it. You would need to write this. Now, moving on, we have 1. Oh yeah, and whenever you find a problem that deals with that you notice as not a perfect square, write this response for that problem. It should be easy to recognize it. Now for case 3a, we have is one a factor? I mean, is 1 a perfect square? Yes, it is. Is 9 a perfect square? Yes, it is. X to the power of 4 a perfect square? Yes, it is. So we have 1 and 1, and then we have 3 and 3, x squared and x squared. And so we just need to write into our formula. So we have 1 minus 3x squared, and then we have 1 plus 3x squared. Now don't forget about your alternating signs. It doesn't necessarily matter which one you start, as long as it begins with 1 and 3x squared and 1 and 3x squared. Okay, so one has to be positive and the other one has to be negative. Okay, and that will be it. That's it for this video. I'll see you in the next one.